Hi, it's Richard here from Past That Science. Question we're going to look at today is what are the advantages from transmitting electricity at high voltages and low currents? So we're going to explore that. Now the national grid within the UK here, the supergrid, operates at 275 or 400 kV. That's some really high voltage. So we may be asked why that is. That's what's in the question. Pure reason is high voltage systems drastically reduce the losses in the system. That's the short answer, but I'm going to explore a little bit as to why and how that is. Well, when we're trying to determine power or power loss, one of the formulas that we can use is I squared R. P is I squared R. So that's a power formula often used to determine power loss in a system. In fact, the power losses are often described as being I squared R losses. That's because it is a power formula. So as it's I squared R, it means then if we reduce the current, it means that we will reduce the power exponentially because it's I squared. Now, in order to reduce the current, we run the supply through a transformer and we raise the voltage up to a very, very high voltage. And then as you're transferring power from one side of the transformer to the other, if you're raising the voltage, you end up lowering the current. So just look further into how that works. Transformers work on the principle that power in is power out. And I'm going to be ignoring the losses for now, just to try and make this easy. And what I'm going to do is run through a scenario. I'd like you to think that maybe there's a factory that uses 0.5 megawatt of electricity and the supply is 400 volts. And to make it sort of simple, I'm going to use 400 volts single phase. I want you to imagine that the resistance of the supply from the transformer to the factory has a resistance of about 0.5 ohm. And with those details, what I'm going to do is work out what the power loss is in the system. Now, the first thing we do, we need to do that. In order to do that is we're going to work out what the current is. So using the formula I is P over V, the power being 0.5 megawatt or 500,000 watts. The voltage is 400, so 500,000 divided by 400 gives us 1,250 amps. That's quite real. Now let's work out the power losses using the formula we discussed earlier. The formula is I squared R. So it's 1,250 squared times by the resistance of the power line, which is 0.5. And that amounts to 781,250 watts of power loss. Golly. So for the next part, we're going to imagine it's the same factory with the same load, but we're going to supply the transformer with 11,000 volts. And we're going to keep the resistance value the same. So imagine the power line feeding the transformer is 0.5 ohm. So working out the losses, let's work out the line current like we did before. So it's 500,000 watts, 0.5 megawatt, divided by 11,000 volts this time, and the current is 45.45 amps. Now when we run the power loss formula, I squared R, it's then 45.45 squared multiplied by the resistance of the system, 0.5, and that gives us 1,033 watts. So the low voltage system losses were 781,250 watts. The high voltage system losses, just a mere 1,033 watts. So you can see then by running the system at a high voltage, you massively reduce the power losses in the system. That is why electricity is transmitted at such a high voltage. Now the system itself, of course we have an AC supply. It may be that you're asked, why do we use AC instead of DC? Well, we've just seen then, in order to reduce the system losses, we run the system at a very, very high voltage, the supergrid running at 275 or 400 kV via a massive transformer like that. Now transformers, when used for that purpose, they only work using an AC supply. They do not work on a steady DC. Even if it's a rectified DC, you don't get the amount of swing, you don't get the peak to peak. with a DC supply rectified. So AC is what we use in this country because that is how transformers work for this purpose. Okay, why does the transmission and distribution operate on AC? It allows us to use transformers. That's all for this one. Now go past that science.